In the next few minutes we're going to take you through all the features of this solar power wagon, and in the months to come I'm hoping we'll have other videos showing other applications of it. What we're doing today is just a trial run to see how well it can run a small mower to cut grass in preparation for hay. A sunny welcome to New Venture Farm, just outside Choma in the southern province of Zambia. This is a very short introduction to a solar power wagon for those of you who, like me, have a very poor internet connection. What you're looking at is the Mark I version of a solar power wagon on its very first day out in the field. You might be wondering what exactly is a solar power wagon. It's an idea that evolved from a conversation I had with my middle son Thomas in February 2015, when we were discussing ways of making this farm more resilient to climate change and to resource limitations. It's about 10 kilowatt worth of solar panels mounted on a low, wide wagon. We draw the solar power wagon with oxen because this farm already uses a lot of oxen, and I did not want to waste good electrical energy on draft, which oxen can provide so well. The solar panels are connected so as to provide about 600 volts output, and that is fed directly into an inverter. This inverter produces 380 volt 3-phase variable frequency output, and today we're using it just to test a small mower fitted with a 4 kilowatt motor. You can see that the mower setup is very much a temporary mock-up, but I wanted to check that the motor was big enough to run this size of mower. What we have seen is that the mower is using so little power that we will be able to fit 3 of these motors to the back, and then the solar power wagon will be able to cut 2.7 meters of grass. I hope to be able to use these solar power wagons without any batteries at all, but I may well find that a small 10 amp hour battery will be necessary to help the solar panels deliver enough power whenever the cloud passes over or whenever the machine is experience a higher load. It took me quite a long time to find this inverter, which comes from Finland. As I said, it takes the energy directly from the panels and converts it to 3-phase, variable frequency 380 volt output. The manufacturer claims that it's possible to connect several of these together with one master inverter, controlling the output of several slave inverters. This close-up view shows you a little bit about what the inverter can inform me while it's running. You'll see here the frequency is starting low and the motor's gradually building up speed, coming up to 43, 44 hertz. I've actually set it to aim for 53. You'll see that in a second. There we are, that's the target frequency that I've given it. Currently it's running at 1480 RPM, but also rising. The motor's only drawing 6.3 amps, and it's only operating at 42% torque, and I think 40% power, 42% power. The motor voltage is currently only 266 volts, and the DC link is only 467. That's because we're only running half the panels at the moment, and they are both covered in dust. The temperature is quite low. It's showing a motor rise of only 3.2%, so the motor is definitely not overworking. We can also release the panels to return to the horizontal position. This may prove essential in windy conditions. This has actually been filmed at our windiest time of the year, and some quite strong gusts of wind may be experienced. We haven't seen anything yet that has threatened to tip the solar power wagon over, but by dropping the panels to the horizontal position, wind should not be too much of a problem. It actually doesn't take 3 people to adjust the panels. My team were just too eager to help. I plan to fit each solar power wagon like a small sailing dinghy, so the driver can adjust the panels from his seat. The solar power wagons cost $7,250 for the panels, $2,500 for the inverter, and I haven't worked out exactly how much the chassis, the wheels, the springs and everything cost. Building the chassis was a much bigger project than I had allowed for, mostly because of the complexity of the steering. We're using many components off the TS90 tractors that I use on the farm, but cutting parts for the wagon from retail steel with a hacksaw or oxyacetylene is definitely not the cheapest way of making them. If I allowed $2,000 for the cost of the chassis and wheels, then the total cost would be about $12,000 per wagon. I estimate that I'll be able to use these solar power wagons for 8 hours a day for perhaps 300 days a year, and that it will then take 6 years to save enough diesel to pay for them. Thereafter, they should be saving me about $2,000 a year. There will be more videos posted over the coming months and years whenever I manage to use the solar power wagons for other jobs. One of my ultimate aims is to have 4 of these in parallel running my TLB digger. In the meantime, I hope you enjoy this video and may the sun be warm upon your back. Thank you.